Everyone's talking about length, and no one's talking about girth. You got me, man. Your comment is 100% right. If we were to use the linear regression that I provided last time, that would assume that everyone's girth is directly proportional to their length. And thankfully for us Chode fans out there, we know that's not true. Any Chode fans in the chat? If we want a truly statistically accurate way to calculate both our PP size, length, and girth, then you're right. We can't use a linear regression. Thank you for keeping me honest. In my defense, I just haven't done a regression in a really long time, and I really like it because, you know bitches love to derive beta 1/2 from the OSL estimators. I'm bitches, by the way. Nice to meet you. So, if we want to calculate our length and girth and have them be correlated but not strictly proportional, all you gotta do is you take your normal distribution for your length and you do this to it. You put another normal distribution on top of it. It's hard to see on like a 2-dimensional. It's supposed to be a 3D model. It looks cooler in a 3D model. Hey, Jamie, can you pull up a 3D model?
300 million people. That means 3 million people are to get peed on.
That is a lot.
That's just in this country alone.
That model might look intense, but all we're basically doing is using 2 normal distributions and kind of layering them on top of each other in like different axes. It's called a conditional bivariant normal distribution. Don't scroll, it's okay, come on. We're talking about Dungeons & Dragons, PP, it's funny! So first things first, let's just go over some notation for a normal distribution, which is our beautiful bell curve here. All we're saying is that X has a distribution of N, and its mean is mu, and its variance is sigma squared. That's basically explaining the normal distribution in notation form. This is how we would calculate our length for our PP. For a refresher in that, reference my Dungeons & Dragons PP Calculation 101 course. That's right, this is a full college major now, because is your college degree too employable? Well, now you can major in D&D anatomy statistics. Because God is dead. Easy enough, right? We have our length locked and loaded. Now we have to find our girth. And in order to do that, I'm gonna have to take this notation, and I gotta do something to it. But you gotta promise you're not gonna get mad, okay? A conditional distribution is gonna look like this. You said you wouldn't scream. You said you need to calm down. You wouldn't scream, okay? It could have been a lot worse. I could have hit you with the probability density function like a FNAF jump scare. So count your blessings, let's move on, okay? I know this looks a little scary, but you gotta just remember that girth, just like length, in a vacuum is normally distributed. So it would look like that. All this is doing is trying to capture the effect of us knowing our length on the possibility of our girth. I can see your eyes are glazing over. I'm sorry I'm not Subway Surfers. Maybe an example will help illustrate this. You remember Checkerboard Chase, right? The minigame from Kirby 64, the Crystal Shards? How could you forget? It's your own personal 9/11. But for those of you who need a reminder, the game works that you are trying to delete the blocks out from under your opponents so that they plummet to their death. The trick is you kind of have to guess and estimate where you think your opponents are going to be because the range of play is so wide and large. But as the timer starts ticking down, you start seeing that the outer layer of blocks gets deleted out, effectively leaving you with a smaller and smaller area of play. Stick with me here. Knowing the length is kind of like those gray blocks getting rid of themselves, and the remaining area is the conditional distribution. Does that make sense? No, you can't have a better example, because there isn't one. Alright, with that cleared up, let's move back into the real world. So, I got good news and bad news. Good news is, for all you size queens out there, I grabbed a new study, and the average penis size is much bigger than the last one. So that's good to go. The downside is, this study was exclusively about Italians. But I know, it's okay. It's okay, Italians don't exist. Purely theoretical people. So with that in mind, this is all pretty standard stuff. Our length is considered x, so mu x is our average length, and our sigma x is our standard deviation, and vice versa for girth, it would just be mu y and sigma y. Eagle-eyed viewers, you'd notice that we pretty much have everything we need to plug into this and start solving for stuff. Except, we need one more little thing. 0.499. Technically, I got this from a different study, not the Italian study, because they didn't have it. But I'm using it here because fuck you gonna do? Sue me? So that fancy little p is actually a Greek letter known as rho, aka the correlation coefficient. Basically, all that does is it measures the magnitude and direction of the relationship between our length and our girth. It's standardized between -1 and 1, basically meaning if it's 0, there is no correlation between the two. If it's closer to -1, that means they are strictly negatively correlated, and vice versa for +1. With a 0.499, all this is telling us is that these two variables have a moderate positive correlation with one another. Do not confuse correlation with causation, okay? If you do, I'm gonna fucking lose it. Correlation just measures the general trend of the relationship. Causation would suggest that one of the variables has an effect on the other, aka that would basically be saying that if you want a thicker dick, all you have to do is make it longer. And as we know, that's not how penises work, okay? If you want a thicker dick, you can't just tie it to a doorknob and then slam the door shut. That'll get you neither length nor girth. All you will get is asked to leave the Olive Garden, which is bullshit because I thought you were supposed to be my family. Some of you guys might remember the correlation coefficient being R in your stats class. That's basically just because R is used when you're working with samples and rho is supposed to be used for your population. But I'm mixing up rho with sample, mean, and standard deviation because fuck you. What are you gonna do? Stop me? You can't stop me. I said that the law of big numbers and the central limit theorem were the same thing in my other TikTok, and only 3 people corrected me. If I said that shit in the wargaming community, I would have been crucified. Also, probably called a bunch of slurs, but lucky for me, D&D has been gentrified to fuck with all of the theater kids and gays, and they are particularly known for their strong math skills. So it's a win-win. Happy Pride, by the way, guys. At the end of the day, this is solid A- work, okay? And even if it wasn't, they already mailed me the degree. I'm not giving it back, okay? I need that shit to perform statistical malpractice. So, with all those variables accounted for, the only thing we need to do now is find our little x. Do you remember how to find x? That's right, using the z-score table. Do you remember the formula, how to do that? Did you just shout at the screen like you're watching Dora the Explorer? Grow the fuck up, okay? But yes, you roll your D100. Good job. So just to remind you guys, this is a bit of a refresher. All you gotta do is you find your z-score, you multiply that by your standard deviation, and you add that to your mean. So, you take your D100. Oof, that's a 92. And that leaves us with a length of 8 inches, which is bueno. Given the fact that we now know our length being 8 inches, we can now calculate a new mean and standard deviation that we can use for our girth. Looks like this. So, this is capturing what our new mean and standard deviation is going to be for our girth, given that the fact that we know that our length is 8 inches. Now, with that, all we gotta do is, say it with me, kids, you did it again. What is wrong with you, man? You're like 25, dude. But yeah, you just do another z-score table roll. Roll like so. That is a 24. So, I'm kind of getting like a Waluigi effect here, which is fine. You know, again, our bodies are beautiful. So we just take that and we plug it in. With that, we have our final answers. So, as you can see here, our girth is calculated in the same way that we calculate our length, but the only difference is we are using our adjusted mean and standard deviation. Because again, this captures the effect of us knowing that our length is 8 inches. You do all the math, and you get a circumference of 5.78 inches. And 8 inches in length, I'd say that's some pretty good starting equipment, baby boy. Or girl. Penis haver. Happy Pride Month. Boom! And there you go. In just 3 easy steps, you now know how to calculate the statistically accurate dimensions of your D&D character's purple worm. Just to recap, all you gotta do is you find your length using that z-score formula, You then plug that in to calculate the conditional mean and standard deviation of your girth, and then you just use the z-score formula again to calculate your girth. And there you go. I got a lot of comments on that last TikTok saying, this is so much work, why don't you just roll 4d6 or 5d20 or just pick a number? And honestly, you're right. You can do all of that. No one is making you do any of this. I just did this for fun. Right? Like, that's the beauty of tabletop RPGs. Really, the sky's the limit, and the only constraints we have are our own imagination. So, get out there and decide what's best for you. I really only did this because it gives me a chance to do a few jokes, engage with the community, maybe refresh your statistic knowledge, and maybe even for some of you, teach you something new. And that's good enough for me. I also wanted to figure this out because I have crippling autism.